try to get this camera right so you guys can see the cutting. Today I am cutting a mold block for aluminum. See if this is right. Got 2 videos, lives, here. Okay, you guys can hear me. Cool. All right. All right. So let me mute this real quick. And all right, that's muted. All right, guys. So I'm gonna start cutting this soon. I've got a 3/8 inch 3-flute end mill in there. It's carbide, and I've got a 1.5 inch thick by 1.25 inch thick. I'm taking about a 1/2 inch off of this. I don't have the material for what I need, so I need to shave down the material that I do have. So I'm taking about a 1/2 inch off of this, but I'm going down a 1/4 inch, about 100th thou per pass. Then I'm going to come back over and cut off the rest of it. And you guys get to watch this. If I screw up, cool. You guys get to see a screw up, and we can learn together. So anyway, this is going to be live. So hope you guys enjoy. Here we go. So right now it's just going to do a ghost pass because I overprogrammed it. And I did a test cut earlier. So anyway, I'm cutting. Okay, it's not cutting yet. Let's see here. I'll mute this so I can see. All right, cool. And here it goes. I should probably touch it. So here's kind of like a spring pass. It's already cut, but it's recut it. Here we go. Hopefully it's not too loud. There you go. Nice, good chips. At this point, I'm just kind of make sure everything runs smooth. Decent sized cuts. Listening for chatter. Looking for any chip weld. I'm going to slow down the spin a little bit. So when you cut aluminum, you really want to be careful with chip weld in the flutes. So heat is the #1 enemy of this thing here. So if you can reduce the heat, then you're good. So this is going both ways, going up and down the cut. I could have gone either way, but I programmed it this way. So just watch this thing. So anytime you're out here machining for the first time, you always want to watch the first program cut, just in case something messes up. Just in case maybe you didn't tighten down your vise correctly. You know, like keeping the material in the vise hard enough in there. I've had that happen before where I forgot to tighten the vise, and it threw the block at the side of the machine. Luckily, it didn't hit anybody or me or a glass window or anything. But anyway, I'm cutting on my MR-1 CNC gantry mill right here. So far, it looks pretty good. So this is a climbing cut right here where it digs into the material. And the next pass is going to be a conventional cut, which means it pushes against it. It's still cutting it, but it's pushing against the material. So those are 2 different techniques in cutting. So a lot of times you'll get a good surface finish with the conventional cutting in plastics and other materials. I usually just do climb cutting, which, you know, keeps the burrs off and all that. So anyway, hopefully it's not too loud. And I'm always looking for, if I put in the tools strong enough inside that collet, because I've had it slip out before also. So you always want to be careful to watch any pulling of the tool coming out of that collet. So if you notice you have like a gradual step down in your material, that could mean that your cullet's coming out, or your tool is coming out of your cullet. So anyway, so far so good. All right, nice stream of chips. So can you guys hear me okay? All right, I'm gonna move the camera a little bit closer. So yeah, this is just some aluminum I'm cutting for a mold. I have a home injection molder that I'm gonna make something with, and I just didn't have the right material, so I'm shaving down some thicker material. I'm just taking about a ½ inch off total right now. It's a quarter inch depth of cut. So yeah, so far so good. Nice chips going there. Is it too loud? Can you guys hear it? I just cut some aluminum on Thursday. It's kind of like grass growing sometimes, watching paint dry. But when you're in person, it's a little bit more exciting because anything can happen. And I've had many things happen, from the workpiece coming out of the vise and hitting something and making a big bang on the inside of my machine, or a tool breaking and flying across the table. So not with this machine though. This machine's actually pretty solid. I've cut aluminum, plastic, stainless steel with this machine. So far, it's held up. But yeah, again, I'm just cutting a mold blank for a mold I'm going to be doing maybe tomorrow or sometime this weekend. Hopefully, you guys will be able to see that video. We're just cutting chips. Always watching for chip weld and any sign of like any weird noises besides the normal. You want to be careful with like loud chatter. So I'm gonna dust off this. So far, so good. Let's see if I can get a little closer there. All right, so I'm about 2/3 of the way done with this pass. I've got one more pass, and actually one more block to do. But we'll find out how this does in maybe about 5-10 minutes. It should be done. I'm kind of slow, just conservative. This is the first time I've run this program for the surfacing toolpath. So this is just 6061 T651. So just watching, make sure it doesn't overheat. If it does, I am next to the E-stop button. Anytime you run these machines, always be ready to hit stop. Good chips going on there. another 10 to 12 passes and it should be done there. So yeah, I'm just again, I'm just cutting a mold blank because I'm going to be cutting in a piece into this mold blank that I can injection mold at home. I've got a hand injection molder that I'm going to use and make a video out of it, and you guys will see what I'm making pretty soon. So hopefully I'll do that video either tomorrow or sometime this weekend. You guys be able to see it. So far so good. Didn't have to use coolant for this one. But usually with aluminum, you want to keep it cool. Use coolant when you can. I'm just trying this out with it dry. See how it goes. So far so good. So far so good. Just cutting chips. Anyway, I got 2 of these blocks to do. I didn't have the right thickness of material, so I'm kind of shaving down some excess material I had. You know, save a little bit of money. But this is just a facing profile here. If you guys don't know what that is, it just means it goes back and forth across the top of the material and shaves down a certain amount of thickness on your material. And usually you do that for, you know, a finish on the top of the material, or just to kind of thin out the material to spec. Maybe give it a little different surface finish. So when this is done, it should be pretty nice. But it's about halfway over for the first depth. I'm going down a 1/2 inch. Right here is only a 1/4 inch. I'm doing it in 2 depth passes. So I got about 3, 4, or 5 more passes for this first depth of a 1/4 inch, and then I'm going to let it run for the next depth, another 1/2 inch. Always watching it so it doesn't do something I don't want it to do. So after it completes this and resets to the first position, I'm going to pause it and stop the spindle. Just kind of check it real quick, and you guys will be able to see kind of like what it did. So another couple more passes and it should be done with the first depth. Maybe 2 more passes. There's one. That's a conventional cut. This is the climbing cut. Again, I'm always ready to hit that E-stop button because you never know what's going to happen. So, all right, after this, I got one more, and I'm going to pause it and shut the spindle down. Maybe one more. Yeah, one more pass, and it should be done. One more. Here it comes. Okay. That's loud. All right, after this, I'm going to pause it. Oh, no, wait, one more. I got this one, then one more back, and then it's gonna retract the head. Okay, last one, and pause it. All right, let me pause it right there. I'm gonna shut down the spindle. Okay, I'm just gonna take a look here, just kind of dust it off a little bit, and you can definitely smell some warm aluminum in here. And yep, perfect. So if you see, it's got a nice shine to it, nice and flat. So I'm surfacing. It was 1 1.25 inch thick material, 1.25 inch. I just took off a 1/4 inch. It's pretty warm actually, and it's going to drop down another 1/4 inch for the finishing pass for the second depth. And cutter, I don't see any major chip weld. You always want to watch out for chip weld. Chip weld is when the aluminum gets welded onto, basically brazed onto the cutter. And if you get too much of that and it gets into these flutes, it stops cutting and it starts melting the aluminum, and eventually bad things happen. Like your cutter will break, or you're gonna put too much pressure on on the vise, and it'll put it out of spec, out of trim, and you could damage your spindle. You could damage any other part of your machine that has pressure to it. So always make sure you don't have any chip welds going on inside these flutes. This is a carbide 3 flute end mill. So anyway, I'm gonna go ahead and get the second pass started and get you guys in the right position here. Get the camera here. All right. Let me know if you can't see it or can't hear it or anything. So, all right. And I'm going to turn the spindle back on and we're going to finish the second pass. Here we go. Oops. Okay, there it goes. Okay, it's going down to the final depth. So that's cutting another 1/4 inch depth. I just took off a 1/4 inch from the thickness of this material. And this is going to be a mold blank for a molding video I'm going to be doing tomorrow or the next day. You guys will be able to see it. Doing something cool. So far so good. Always stay near that E-stop button just in case something unexpected happens. Or maybe it's expected. Depends how you program this. And so far so good. All right. All right, here goes the next one. Yeah, just cutting some aluminum. This is a T6061. I'm sorry, this is 6061 T651. It's just a type of temper. Most people don't really care about T651. They just think of 6061 aluminum, and people say, "Oh, that's aircraft aluminum." Well, yeah, sure. There's different types of aircraft aluminum, different types of temper depending on what you're using. Basically, 7075 type of aluminum is like tooling plate because it's more dense and it'll hold threads better, and that's what you basically make tooling fixtures out of. It's a lot more rigid. But other stuff, maybe 5052, it'll anodize better. So different aluminums have different characteristics that that'll work for whatever project you're working on. So I anodize some other aluminums, and it's just 6061. I think I'm sorry, it's 5052. So I guess it anodizes better. Wow, I can't talk. It anodizes better than other aluminums. So 5052, 5053, I think too. So also on my toolpath, I'm looking for the difference between the bottom of my cut and the top of my vise to make sure I have enough clearance. I don't want to cut into my steel jaws on my vise because then I'll ruin my steel jaws there. So far so good. The cutter's holding up pretty good. I don't see any chip weld, and it's just cutting smooth. I've got one more of these blocks to do, and I should be done. I'll be ready to make a mold for my injection molder that I have. And I have some plastics. I have TPU, which is like a rubbery type plastic I'm going to use. One of these days, I'm going to make a video on some polypropylene that I have. I have different colors polypropylene. Um, so anyway, for the hand injection molder, I have the MK2, which is from Buster Beagle. I think that's what it is, Buster Beagle. But you can get a kit online, build your own hand injection molder. Um, just look up Buster Beagle 3D, I think it is, and you'll see there's different models. I first got the MK1, which is I think a 1 square inch, or 1 square ounce shot size for plastics, and I wanted something a little bit bigger. So I got the MPI-2, and I actually put two of those barrels together. One day I'll show you guys, but it actually does about 2 ounces of plastics. Just a good size for small parts. But I'm going to be using TPU, black TPU for this project here. Sorry, guys. All right, so far so good. So right now I'm listening for any weird tool chatter or any really loud noises because that's an indication of chip weld or something else that's come loose. Again, anytime you do a program, you want to test it out before you go full production. If you're going to do production, I could go a lot faster than this, but I'm just being conservative because I want to have enough time to stop it if I have to. So, I mean, it's going fine right now. It did the first step pretty well. A quarter inch. This is another quarter inch step. 100,000 step over. Nice size chips. Nothing too crazy. So, yeah, when you're here live, it's a little bit louder. Sometimes I'll have to wear earplugs, just a constant noise, but this is not too bad. So, let's see. Can you guys see it okay? So just cut some aluminum. That can be the challenge when you get into CNC machining is sometimes these cycle times are pretty long, and you start to daydream and zone out, and it just takes a while. Like I've had over an hour cycle times for some of the projects I've done. I mean, some guys can vouch for probably 24-hour cycle times depending on what they're cutting. There's a thing called lights out manufacturing. Basically, the machinist sets up the sets up the machine, puts in the material, starts the program, shuts off the lights, and goes home, and comes back the next morning, and depending on how long it takes, might be done, might not be done. But you don't want to hang around for 16, 20 plus hours watching a job just run, if you got nothing else to do. I mean, if you got another machine you want to work on, it's something you can kind of peek on every so often, if you have multiple machines. But yeah, that's called lights out manufacturing. I wouldn't recommend it because, like I said, anything can go wrong. It's a machine after all, and a human programmed this, and humans make mistakes too. So you just got to be very careful. And I mean, if you get through a long program and it's proven out and everything's locked down and you have more trust in it, that's different. Then you could probably let it run, go to lunch or something like that. It really depends on your tolerance level, your type of machine, what program you're running. But yeah, I mean, just aluminum, not too much can go wrong. The wear on these toolings for aluminum is a lot less than steel. Steel's a lot harder, so it's going to wear down your tooling a lot faster. So just be aware of that. But the biggest thing with aluminum is, like I said, heat and chip weld. When you get the melted aluminum inside of the flutes, that's it stops it from cutting. That's when bad things happen, or could happen, unless you stop it. I've stopped jobs where I just knew there was some chip weld and I had to stop because maybe the coolant wasn't getting to it or something. And so I stopped it, replaced the tool, and just continued from that point. So that's one thing you got to kind of pay attention to. And a big indication is if you see this edge of that part right there, the burrs. If those burrs look more and more solid and maybe like a mini tidal wave, I guess, then that's also an indication of the aluminum getting too hot and you're starting to get some chip weld. Like these burrs are not too bad. If my tool was a little bit newer, a little sharper, you wouldn't have that many burrs on it. But I've used this tool more than a few times, so it's expected. But yeah, just cutting aluminum here, guys. So, but yeah, I plan to turn this into a mold and make a video about what I'm doing. Like I said, maybe tomorrow, the next day. So, so far so good. I think I have about maybe 8 to 10 more passes, and this one should be done. And I'm gonna change over to the other block and machine away again, and I should have 2 completed mold blanks. And then I'll videotape the mold I'm going to be doing. It's a really simple mold. It's basically just a cable organizer made out of plastic, TPU plastic. It's kind of like a rubbery type plastic, and that's when I have a bunch of those pellets. But that's what this thing is going to be when it's done. So yeah, I got maybe 4 more passes, 6 more passes, something like that. I've got some air passes at the very end. I'm gonna stop it when it finally finishes its last pass, and just kind of show you guys. But just it's almost over, so let me move it over a little bit. You guys can see it a little better. Sorry. Go down. There it goes. Ouch. That is hot. Sorry, guys. All right, I got one more pass, I believe. Yep, a little loud. All right, after this, I should be able to stop it. And all right, cool. Let me jog the spindle up. Get it out of the way there. All right, cool. A lot of chips. This thing does create a lot of chips, but there we go. So yeah, here's the final machined block right here. Nice and smooth. Ooh, it's warm. All right. So yeah, I've got a lot of chips to clean up in my machine, but that's just part of the game. But that's okay. So I can either get a vacuum and get this off, or sweep it up. But anyway, I just thought I'd get on here and show you guys a live aluminum cutting demonstration. So anyway, if you guys like this type of content, maybe CNC machining or um, any type of creative stuff like this, like I said, I do injection molding too. So um, anyway, hope you guys enjoyed it, and I will see you next time.